So when we work with time series datasets, we come across two types of dataset, which are stationary time series and non-stationary time series. So basically a stationary time series is one whose properties do not depend on the time at which the series is observed. So the time series with trends or seasonally are not stationary in that case. In general, a stationary time series will have no predictable pattern in the long term. However, the problem is that when there is a non-stationary time series, we have a problem fitting the conventional time series models for these types of datasets. So in these situations, we have to convert the non-stationary time series dataset into a stationary dataset. So for that, in R, we can use a technique called differencing. So for this example, I am going to use Bitcoin value over the start period in 2014 to 2021 June. So first of all, let me create a time series day object from the particular CSV file. So therefore, to do that, first of all, we have to filter the Bitcoin value data series only, because the current dataset we have a time also. So I know that the dataset related to the Bitcoin value is in the second column. Therefore, I am going to extract only the second column of the CSV file. So then we can call the TS function to create a time series object. So we can give the starting date, which is 2014 January, and then the end date 2021 June. So we can specify the frequency as 12 since it is a monthly data set. And let's plot this and see how the data is arranged. So now you can see, so if you look at the graph, you can see the Bitcoin value is almost stationary over the years at the start until 2017, and it goes for a spike in 2018. So there are two methods we can use to check whether the dataset is non-stationary or stationary. So first of all, I am going to use the autocorrelation function to check whether the data is stationary or non-stationary. So let's run this. So by looking at this ACF plot, we can see in most cases the ACF value crosses the significant value, which indicate the dataset is non-stationary. Therefore, we have high number of future values correlated with the present values. So apart from this method, we can also verify these results with the ADF test, which known as the augmented Dickey-Fuller test. So for that, we can call the ADF function. So in here you can see the p-value is greater than 0.05. Therefore, we can accept the null hypothesis, which is the dataset is indeed non-stationary. So in these situations, we can't actually use the classical time series function. Therefore, we have to use a technique called differencing to get to convert the current dataset into a stationary time series dataset. So before I do that, I want to explain more about this ADF test. So ADF test is a common statistical test that we use to test whether a given time series is stationary or not. So it is actually the most commonly used statistical test when it comes to analyzing the stationary of a series. So to convert the non-stationary dataset to a stationary dataset, we can call the diff function. And then we can see the plot also. So in here what we do is we take the difference between the value at present time and one time previous. So in the function, the y-axis gives what is called the first difference value. So you can see when compared with the previous original values, the upper has been reduced, as well as the current plot has positive and negative values also. So like previously, now we can again call the ACF2 function and ADF test to check whether how the values has been changed. So let's do that. So if we run this ACF test, you can see the number of ACF values past the significant value is now only 1. So in the previously we saw there are quite a few numbers goes over the limit of the significant value. So furthermore, when you conduct the ADF test, you can see now the p-value is less than 0.01. So now we can accept the alternative hypothesis, which is the current data set is stationary. So in this way, by taking the first differencing value, we were able to convert the non-stationary dataset into a stationary dataset. See you in the next video.